Ayan, okay. So, what's the problem? What do you like to your function? Okay, the reason. Okay, okay. So the reason first. Materials and apparatus. Patient between us. So, as I said a while ago, how will you proceed with doing your laboratory? What's the most important thing before you do any laboratory work? You have to have your what?
You need to have your samples ready.
No, I mean you have your laboratory manual, right? You do
Yeah.
have this something so that
Pretest.
you have a grasp. What?
Pretest.
No, you should
You
do
s-
pre-lab, laboratory, your notebook or
Oh yeah.
module. Okay, so
Okay.
I gave you an example last time. So it has your schematic diagram. So an example of a schematic diagram is like this. So based on your procedure, we can do a schematic diagram. So the purpose of a schematic diagram is to know if you can visualize steps. So in the laboratory, you'll be having a hard time to do the lab if you just base it on the text. So what we do, for example, let's focus on letter A. So how will I do it? So provision of example. So let's go with just go with our okay, so our I don't know if I can add a photo here. Browse. Okay. Resets. Okay. So this is how you do a schematic. No? So this is a technique that we do, or actually it's not a technique. It's a requirement we do before we go to the laboratory to make sure that we really know what we're doing. Oh, bakit yun? What the? Wait, I'll just save your. Okay. Then file, browse, load my 14. Okay. Ay, ito pa rin. Kasi si May. Downloads. Okay. Give a minute. It's downloading. Okay. So here's your ano, no? Procedure. So this is how you do a schematic. I think you're doing it. Are you doing schematics ba? Before the lecture? The laboratory, I mean.
Not as far as I know.
So, okay. So letter A. So measure the needed mass. So what you do is schematic diagram. And then you have your okay. You measure the needed mass. You have your setup here, your beaker. How do you measure? You needed the mass. You get from your container. How many mass daw? 100. Measure out the needed mass to prepare 100 ml amino acid. AA. Okay. 100 ml amino acid. Solution for the whole class. So, syempre ito, that's for the monitors to do. So, how would you do that? You have your 100 ml of your amino acid. What are your amino acids? Say 0.1 m of glycine, which is a pH 1.0. Oh, sige nga, how would you prepare 100 ml amino acid?
Is there like a formula for it?
Wait. So the formula for that. Okay. So we discussed this last time, right? So like for example, if you need a certain grams of your acid or your base or your protein, given the molarity, which is for example in this case 0.1 molar, what are the steps? Ah, sige nga, oh, kunyari, dito tayo kay glycine. So what are the steps you need to do to produce a 100 ml amino acid, 100 ml of 1 molar glycine?
Does Henderson's Hasselbalch equation still count or
This is not a buffer, right? So you just have to like dissolve it in water.
okay.
So mm,
Wait.
you can annotate if you want to. What can I add? Why can't I add the T? Are you annotating? Sorry.
No, I'm just trying to figure it out.
O sige, I'll give you 2 minutes. You give me the grams of glycine needed. But don't mind the pH one. Just have to,
With 0.1 molar glycine or
yep. Huwag
2
muna natin
grams?
tuloy. Yes.
2 grams, okay.
How can I edit the font type here? Kasi parang last, okay. Oh, okay. Ano pala? Oh, i-focus muna dito. How would you produce a 100 ml, I mean, of 0.0 molar glycine with pH? Oh, don't mind the pH muna. Mangin. Okay muna natin. So if you understood what we did last time, you'll be able to answer this in less than a minute, actually.
Is it weight over mass times volume?
Can you show your solution? Are you annotating yourself?
No, I haven't started yet. I'm just trying to figure it out. Is it?
It's you just have to multiply stuff. So weight times what? Sorry, times
No,
mass over.
weight over mass times volume? Oh, sorry, weight over molar mass times volume.
Mm, it's the other way around. You should start with the molarity.
Okay.
Okay,
Zero.
I'll give you the solution. So,
Okay.
last time we discussed this, di ba? So this is mole over liters, right? Oh, let's say we start with millimoles per ml. That's the same with, actually, it's the same with moles per liter. But for the sake of the tutorial, so I guess you know that one molar, 1 molar is to 1 mole per liter, right?
Yeah.
Correct, correct, right?
Hmm.
And it's also the same with 1 millimole per milliliter because they just cancel out. Because this is on
Hmm.
millimoles, this is on milliliter. But this has a greater value. What do I mean is this is still 1 molar. This is 1 millimolar. Okay? So it's like 1 gram, 1 kilogram, you know it naman. And then so delete natin yan. So you start from here. Liit naman ito. Okay. Ah, ano ito mga ka? Kasi, okay. Mm, let's make it bigger.
Hmm.
Okay? 1 mole per liter. Diba yan? Multiply mo with what's given? 100 ml. Should
100
we
ml.
multiply it by 100 or by what?
You're saying over? Why should it be over?
No, we have to
Zero
multiply
point
it.
0.1.
Correct. 0.1 liter. Oh. Kasi di ba, from 100 ml to liter, you just have to multiply it by 10 raised to negative 3. Correct?
Yeah.
That's why you have liter. So later you'll see, no, why? Mm. Afterwards, you have to multiply it what? With,
Multiply.
you have your moles na. Kasi in this case, this will cancel out, right?
Yeah.
Oh, what will you multiply?
Is
To
it
You'll have to
uh,
multiply with
the mole of glycine, or it's already there?
the weight of glycine, right?
Oh,
Per
okay.
molar mass. So what's your
Okay.
molar mass? It's grams per mole, right?
Mole. Yeah.
What's the molar mass of glycine?
Is that like is there like a definite like answer, or
Yes. So
okay,
let's
molar
see.
mass?
Right? What's the molar weight? When you say molar weight, molar molar mass glycine. I forget this, but it's
75.
75.07. Okay. So when you go here, mm, this should be 75%. I'll get your calcu. Okay.
Okay.
What happens is this will cancel out, right? Kasi ito yung nasa taas.
Yeah.
Okay. O, you do the math. 0.1 mole. Ang hirap na. Mole per liter times 0.1 liter. This will cancel out. O, multiply by 75.07 grams per mole. Since you have your mole below, this will cancel out. So, anong matitira? We have,
0.1 times 0.1 times
yes, multiply
75.07.
this. So, it's what? 0 point,
0.750 7,507.
correct. Yan. So, to create a 100 ml of glaze of 0.1 glycine, you have to dissolve what?
7,507 grams.
Correct, of glycine in water. Okay. So, we have that value, right? Okay. Delete na natin
Okay.
siya. Okay. So, the 757. So, you get naman, no, how we do this, no? Okay.
Okay, I got it now.
We have to delete that. So, for the schematic, you have to input 0.7507 grams. And then you have to weigh this, right, from your container.
Okay.
Oh, this is your weighing scale. Oh, you weigh 0.750 grams. Oh, as when you weigh it, or you have your beaker, oh, you put the weight, no, and then you just dissolve it with water. 7507 grams, and then add water. Dissolve it with water. Oh, oh, that's the first step. So if you don't know what is, if you don't know how to do the, or how to get the grams of your glycine from 0.1 molar, you'll have a hard time. Okay? Or later, sige, I'll give you a, ano muna, I'll cut you some slack first kasi this is step-by-step procedure. So later you'll do it on your own. Okay, so we're done with step 1. Mm, for the whole class daw. 100 ml lang naman kailangan mo. Okay? So we're done with preparing this. Actually, no,
Okay.
not yet. We're not yet done kasi we're just in number 1. We just want to focus here. So number 2, dissolve the solid amount of water, no? Oh, less than the desired volume, greater than the desired volume. So if you want 100 ml amino acid solution, you have to dissolve it in what?
Water.
Yeah, in greater than the desired volume. So if you dissolve the solid in appropriate amount of distilled water, it should be greater than 100 ml. So as long as yeah, because you preparing 100 ml in volumetric flask, right? So you dissolve it. Acidified the solution using 1 molar HCl. So how would you do that? So the next step would be what? So you have your solution, no? Or your solution with that you insert a pH meter, right? Remember
Yeah.
what's the purpose of
Yes.
pH meter?
To find out the pH of the solution.
Makes sense. And then you pour your acid here. This is 1 molar HCl. And then you check the pH. Are you done when the pH is around 1.3?
No.
Okay, so what should be the pH? It's around 1, right?
1.00. Yeah.
Okay, correct. So in this case, since this is a biochemistry class or you're preparing in a laboratory, it should be near 1. No? Pero
Yeah.
in real time, 1.1 or 1.05, as long as it's near 1, it's okay. But 1.2 also good. But yeah, if you want to be technical about it, just 1.1 is the right answer. Okay, if you have
Okay.
1, the next step would be, so we're done with 2, we're done with 3, transfer solution, and fill the mark. So here's your volumetric class. That's like what we did before. This is your mark.
Okay.
And then you just have to transfer the solution. No? So let's say here's your beaker. And then you just have to transfer it to the content mark. So that's how you visualize the procedure. So do you understand now when, for example, I remove this, if I remove this, like, you understand what's happening here, right?
Yes.
O sige nga, from here, what's happening here?
Okay. Okay. We'll go through it again. Okay. So we needed to weigh in a sample from our glycine. So to do that, first we had to solve how much we needed,
Wait,
which was zero.
can you use your cursor to annotate?
Okay.
Like,
Uh.
mm,
Okay. Okay. So we needed to get a sample of from 100 ml amino acid. We need to get a sample of 0.1 m glycine. So by solving that, we got 0.7507, which is here. Um,
mm,
we put it into the beaker, right? Put it into the beaker.
mm, mm,
We had it measured under the weighing scale, and then it
mm,
was proven to be accurate. And then once it became accurate, we dissolve it with H2O, right?
mm.
And it has to H2O has to be greater than the 100 ml of amino acid,
No, not
right?
necessarily. You just have to dissolve.
Okay.
So that's
And then once we put it into our beaker, we add the hydrochloric acid, this is HCl.
yes.
Yes.
Mm,
And then we check with our pH meter if it's within one has a pH of 1.0.
okay.
And then we fill it into the flask, right? This is a flask, right?
Yes.
Okay.
What's the volume of the flask?
volume of the flask. Is it
Mm-mm.
250 or is it
No,
100? 100?
based on your procedure, you need to prepare 100 ml of your amino acid solution. So the flask should be
100 ml.
correct.
Sorry, I got
Then,
confused with the two.
okay. So, okay. Oh, that's good. So,
Okay.
diba? You get it now. So, that's how you do it, no? When you are preparing solution. So, every time before you go to class, it's best if you do schematic diagram. I guess, weren't you, um, I mean, aren't you assigned to do schematic diagrams before laboratory class or what?
It's never really been mentioned as far as I can remember.
Really?
Yeah.
Oh, okay. Oh, that should be a practice for you if you have to pass this biochemical. Kasi your professors were our professors in the major, so they're
Okay.
very keen with doing schematic diagrams. So I think it's plus point and also a skill, a discipline to do schematic. Okay.
Okay.
Okay. So I did the glycine, you did the aspartic acid. I'll give you 10 minutes. If you want to annotate now, you can. I'll delete
Okay.
that.
Yes. Yes.
I'll delete the drawings. I'll go.
Okay. Okay.
10 minutes, ah.
Aspartic acid. All right. Sure. Sure. Um, this is zero point
Sige,
0.1.
I'll give you 15. No, 15 is
50.
long. 10 lang.
Okay. So okay. I'm assuming the aspartic acid, it's the same as the glycine, right? It's not. Besides the weight, it should be the same,
Yes.
right?
The process
Okay.
is also the same. So you can
Okay.
annotate. I won't give comments. I'll give comment after 10 minutes.
Okay. Yeah, I'll just annotate this. Okay. I can just type 0.1 times 0.1 times IR. Um, okay, I'm done, I think. I think, yeah, it's
Okay, so you do the schematic, the drawings, or you
Oh
can
yeah,
type.
sorry. I
Mm.
forgot. I'll draw it.
Oh, delete ko siya para walang cheat sheet.
Okay.
Hindi. Just, don't cheat ah.
okay, wait. I'm trying. Hence not working. Okay. Uh. Okay. So this is.
Mm. Oh, you have a bigger space now.
Wait, no. Okay. Uh. And then. Okay. Done.
Okay, let me see. Sugar mama. Okay, I assume you did the math. Okay, amino acid. So what's this? What is this 0.1 and amino acid?
It's supposed to be the aspartic acid.
Yeah, so that's what we're looking for. Okay, so that's from the container, and then you put it on a waster, right?
Yeah.
Okay, explain it to me from there.
Okay, so we measured up the weight and then we need 1.331 grams of aspartic acid. We then add that with our H2O. Uh, and then we add, okay, this kind of got weird but we add is it 1 mole of HCl?
1 molar. Yeah, correct.
1 mole of HCl. And then we measure the pH to see if we reach 1.0. That's what we're looking for as
Mm,
for aspartic acid. And then once we reach the required pH, that's when we add it to the flask, the 100 ml flask.
Okay. Okay.
Okay.
That's great. So before that, I have questions. So in
Okay.
here, you told me you'll be inserting 1 mole of HCl. So I have two choices with you. You put 5 ml, you put drop one of 1 mole HCl. Which will you choose? 5 ml
Dropwise.
each. Why?
Because like just so you can measure it bit by bit just to make sure you don't mess up with the pH.
Hmm, that's a practical sense, correct? Um, Technically, you want to pour dropwise of your ACL so you can minimize the change of pH. So let's say if you pour 5 ml of your 1 molar ACL, there's a chance na the pH of your solution can be from 1 to an abrupt change of, let's say, 4. So you have to pour sodium hydroxide just to make it go back to 1. And mind you, putting a lot of hydrochloric acid or sodium hydroxide produce what? What type of ions?
Bad. It's bad for you. Type of ions.
I know it's
I'm not
bad.
wrong. It's bad.
No,
Okay.
you're correct. I know they are it produces cations and ions that are unnecessary for your protein or for the solution, right? So we want a
Yeah.
pure sample. That's why we should be careful on putting our adjuster. So we call this buffer adjustments or adjusters of solution. So usually it's a strong acid or strong base. So correct. That's you're correct that we should put that one. Okay, second, we go back here just to clarify. Uh, are we correct when we say we should dissolve it in 100 ml or it should be less than 100 ml?
It should be 100, right? Because that's what they're asking.
So a while ago I told you you should dissolve it greater than 100 ml, which is wrong. Why?
Because you might dilute it.
No. Okay, I have a clue for you. What's the volume of your volumetric flask?
100 ml.
So if you dissolve your protein, solid
Greater.
protein in greater 100 ml, what would happen with your
Well, it's
solution?
first up. It's gonna go over the flask. Oh
Oh,
gosh.
correct. So it's more of a common sense question. So based from our discussion, how many water should you dissolve your protein with? Protein in?
Either 100 ml. It
No, mali rin ang 100 kasi you
has to
have
be
the
less.
volume. Yes, the volume of your protein can add to 100 to the volume
Oh,
of
to the
your
already.
solvent, right? So if let's say the volume of your protein is around 2 ml and you pour 100 ml, so it's greater than 100 ml. So when you pour it
So
in a volumetric flask,
98.
it's no, it's just a common sense question. So at first, our goal is to dissolve your protein. So you can dissolve it like less than 100, let's say 80,
Yeah.
right? Kasi you'll be putting dropwise of your HCl or your sodium hydroxide. So if
Okay.
you add 100 ml, can you adjust it with the dropwise of your adjuster? Di ba hindi na?
Yeah.
So it's the best thing if you can dissolve it at 50 ml or less than 100, let's say around 60. That's a good thing. So you just have to weigh the pH meter, no? And then when it's around 1, you dissolve it with water until 1, right?
Hmm.
Okay, correct. So the technique there is, so you have your correct, no? So here's your grams, and then you have, let's say, 70, no? 70 ml of water. And then you adjust it with your pH meter. Afterwards, no, you pour it with your volumetric. So we know that it's 70, around 70 to 75. You add another 25 ml, no? 25 ml or another volume of water until your mark. Do you
Okay.
get my point?
Yes.
If you add 100 ml, how can you adjust your solution, your pH?
Hmm.
Correct?
Yeah.
So I understand why is it less than 100?
Yes, I get it now.
Okay. Sige. Um, ano pa ba?
I have a question.
Okay, sige.
Okay. So we already solved 0.1 m glycine and 0.1 m aspartic acid. But what happens if it's 1 m of HCl, hydrochloric acid?
It's the same.
But
The same
okay.
as this. Hmm. Sige nga, solve mo. Or delete all drawings. Solve
Okay,
mo.
okay.
In 1 minute, dapat kaya mo na yan.
But wouldn't the formula change because we're asking
No,
for
it's still the same. So let's say, oh, magkano ba, ay magkano? How much HCl do we need?
1 m each?
Yeah, but the volume. I'm referring for the volume. Wala siya sinabi dito, so it's up to you. How much will you use? Or let's say, you prepare 100 ml of 1 molar HCl. How will you do it? Sige nga, so I'll give you 3 minutes. Or 5,
Okay.
3. Mm-mm.
All right, let's go. 0.1. So first, I'm gonna connect my I have a mouse also. Okay, there we go. Wow, that's
If you want, you
so
can type.
much. I put my mouse in that's so much worse. I'm
Mm.
removing it. Okay. Um, okay. Text. Uh, so if originally it was 0.1 mole times times 1 mole of HCl, molar mass of each. Oh, oh, that's great. 0.1 mole.
Oh, 40 seconds.
Oh, okay, fine. I'm the Eggman. They are the Eggman. I'm the walrus. Pikachu. Ah,
Okay.
it really
Let's
rings in
see.
the ears. Oh.
I'm sorry. Okay, let me see. Is it 36? I think it's 39. Whatever.
It's diluted.
Uh, No, don't worry. You don't have to do the schematic. I was just asking for the solution. Okay. Your solution is correct. Ah, no. Let me see.
Oh, it's gone.
So, okay. Your process is correct. No, your process is
Okay.
correct. Although this should be one. Kasi di ba, sabi dito, one lang.
Oh,
Right?
okay. Okay.
So it's, you have
Oh,
to dissolve 4 grams in 100 ml water.
oh,
Did you
okay.
get it?
I get it. But my
It,
okay,
it,
so
it
let me just confirm
okay,
this. So
go.
this used to be the 100 ml of water, right?
Mm-hmm.
And then this is the 1 m of hydrochloric acid.
Yes. Yes.
Okay. And then this is the molar mass of the of the hydrochloric acid.
Yes.
Let me
I
write
think
that.
it's 40, not 36. Where did you get 36?
I searched it. Was I
Really?
not?
Okay, what? Okay. So you're like, oh, that's correct. You're learning. So it's the same with the others, no? With phosphoric acid, which H3PO4, H3PO4. We discussed that before. Is it? Oh no, palaki na natin. So this is your H3PO4. Mm-hmm. So H3PO4. So same
Yeah.
goes, no? Same process with everything. Also with this. Okay, I have a question with you. What's the purpose of the serological pipe or a pipette in general? Where do we use or when do we use a pipette?
Serological pipette, isn't that the one that like you can use your thumb to like
You're correct. So why do you use your thumb? You have to transfer what?
it sucks in liquids, right? And then you can
Oh
drop
yeah.
it.
Okay. Good. That's good, no? You suck liquid. In technical terms, you transfer solutions using your pipe. So for example, you have your stock solution of your, let's say you made a 0.1 molar um, glycine, right? So if you use it in your experiment, for example, have a beaker, and you just need around, let's say, 10 ml, or let's say one. Based on your protocol, you just need one down, one. Or your serological pipette is used to get a total volume of one, and then transfer it to your test sample, your beaker sample. So
Okay.
that's how you use a serological pipe. Ball flask. Why do you use a ball flask? Where do you use ball flask? Your volumetric.
Volumetric flask. You will use it to measure stuff.
What is that stuff? Ano pa ba? Di ba kanina, we said that we should use ball flask, your volumetric flask for what?
To contain like a specific volume.
Okay.
Like
So, okay. That's good. That's correct. So you use a volumetric flask to to create a certain solution with a certain concentration. So if, for example, we want to have our 100 ml of 0.1 glycine, so the volumetric flask says that the solution inside is indeed 0.1 molar of glycine with a volume of 100. Now you get it, why we say 100 ml of 0.1 molar glycine.
yes, because that's what flask is for.
Mm-mm. Mm-mm. So, for example, no, eto, is this the same with this? Are they the same?
No,
Why?
because the amount of the grams per Y? Is that Y? Or liter?
This is glycine.
Oh,
This
the
is
amount of
glycine.
glycine, the amount of glycine is different. So of course that affects the how many is in 100 milliliters.
Yeah, so which of the following blasts, one or two, has a greater glycine content?
One.
Correct. Okay, you get it naman. Uh,
Okay.
what if I, but how about this? Like this, Pareto, 200 ml. Are they the same? Are they the same?
0.1, 0.1. No,
Yes.
no, this is less. This is less. Number one is less, is it not?
No, they're just the same. They're different
But
with their
different.
concentrations
Sorry,
are the same. Okay. Oh, what are you
I
saying?
mixed up my
What you're saying?
words. Sorry, I meant that
How?
it's less because the thing is bigger. The flask is
Mm-mm.
bigger.
So, like for example, they're the same, but the flask is bigger. So, like for example, if you get 1 ml of this, no, and then 1 ml of this, it's still 0.1 molar. Okay. In this case, you have a greater volume but has the same concentration. So it's like you're having twice of this, but there's still the same concentration. Okay. Like for example, if you prepare two of this to create this, oh, you get my point naman.
Yeah.
Okay. Okay. So, yun. Where were we? I guess we discussed procedure A.
You want
So,
go to procedure B?
okay, oh, isend mo sige. We have
Okay.
33 minutes. I
Okay.
thought you were gonna ask about the lecture part, like for example, amino acid structure. So you can study naman that on your own. There are
Yeah.
a lot of videos. Mm-mm.
Okay.
Oh, let's go to procedure. The
Oh,
next one.
what what happened to the I requested videos, right? If there's ones on remember I asked for if there were any videos that were still being
You
what happened?
can send an email to LRC because I don't have an idea of those lectures. So,
Okay, it's okay. Okay,
mm,
this is part B.
lol. Okay, so let's take a screenshot. Sorry. Oh shoot, sorry. Hey. Oh, oh, what do you want to know about this?
So prepare 10 ml of 0.1, 0. Is it the same thing we did in part A or it's different? It's different or
Uh, you have already the concentrations of this, right? We already created this, right? So you just have,
yeah.
when you say prepare, you just have to get 10 ml from the stock solutions.
Okay, so from
What do I
what
mean
we
the stock
got.
solutions? Hmm. Those the ones that we created on part A, you just have to get 10 ml. Oh, and then what?
Okay, and then just put them in separate 250 ml beakers. All right, I get that. Let's I'll systematic. So let's
Oh,
say
actually, you
like
can do a schematic here. I'll go.
I look I already am. Ooh. Okay, so
Is that a beaker? What's that?
thinking, uh oh yeah, sorry.
Okay.
Okay. Let's okay, so this is the 250 ml beakers, and then this is H.
Mm-hmm.
It's the glycine. So this is from the stuff that we just did, right?
Yes.
So we put it
Okay.
into these 250 ml beakers. So wait, so this is it once we've already added the 100 ml of water.
Yes. So
Okay, so
just
it's
have to
already
transfer. Mm.
okay, so we've
Okay.
transferred it already. Record the initial pH of the solutions. So we add the this guy
So I guess
pH.
for number two, it's self-explanatory, right?
Yeah. Okay. So we record the initial pH with this, the pH mesh.
Which
Titrate the
meter?
solutions. Titrate the solutions with 0.1 mA.
So do you know how to do titration?
It's when is it the one where it's like so there's the little like knob here. Is it this one?
Yes. Okay.
Uh, good. I've never done titration alone before, so
Okay. O sige. I'll teach you how to do how to titrate. Oh, okay. Wait lang. How do I hide annotations? Okay. Teka lang. Oh, okay. O, sige muna natin ano to. Don't know how to. So this is how you to titrate. So typically you have your pipette and your acid solution. So what do you call this? What do you call the solution inside your flask? This is your flask, right?
it's
Or what do you call this flask?
uh volumetric.
No. What's the difference of a volumetric from an Erdenmeyer flask?
Volumetric, you just use it to measure, right?
Yes.
Well,
So
okay.
sige nga, which of the following is a volumetric flask?
Oh, it's like Breaking Bad. Oh gosh.
Oh, versus this one. Oh, based on from the shapes, which is the volumetric, which is the Erdenmeyer.
The rounder one is the volumetric one.
Correct. This is the volumetric, Erdenmeyer. So the one I show you, okay, the one I showed you a while ago is okay, Erdenmeyer. You put an acid solution from a pipette. What do you call this acid solution? So in titration terms, it called the what? Starts with letter A.
A one, two.
Mm,
The acid solution being poured is called the
yun nga. Because analyte, no, the
analyte.
analyte has an unknown concentration,
Okay.
no? So we don't know the concentration of your analyte. So you put an indicator, no, to see the changes, no, of your solution. So later I'll put what's the purpose of the indicator. The indicator changes color upon pH change. No, there's a
Okay.
certain um pH, like for example, phenolphthalein. This is a phenolphthalein. This is a known pH indicator that changes color from clear to red from pH, I guess, 7 to 8. No? It changes color
Okay.
from clear to red. Okay. Okay. As you can see, no? Let's say the green one is a phenolphthalein, but in real life, phenolphthalein is colorless. No? In
Okay.
this case, you put an indicator here, and as you can see, the solution doesn't change its color.
Okay.
No? Okay. So in this case, so this is your burette, the one with the knob that you're saying. Oh, this is
Yeah.
knob is closed. And you put the titrant. So the
Okay.
titrant in this case is the yellow, is the orange one. So you have your decal, no? Then you pour it here. So usually this is a base, no? This is your base. So in this case, for the sake of our topic, it's your sodium hydroxide. So this is your acid solution, your hydrochloric acid, or your proteins. So why are your proteins acidic? I mean, in the prepared solutions, why are the proteins coined as acidic? What's the clue?
Acid base. Is that the relation between acids and bases?
First, because if you have an analyte which is an acid, you should have a base of a titrant, right?
Yeah.
Second, a while ago, we said that we have to prepare the amino acids with pH 1. O from there pa lang, acidic form sila. Because
Okay.
your amino acids has the pH 1. So pH 1 to 6 acidic, pH more than 7 basic, right? What's the
Yeah.
neutral pH?
Neutral pH.
What
Like
uh
overall or amongst the
over overall?
isn't like the one that humans have is the neutral pH?
Yeah, it's pH 7. So below 7 it's acidic, above 7 it's basic. So what's the pH of
Okay.
water? Conceptual lang to ah. What's the pH of water?
6.5 to 8.5 because plus one or minus one, right? 7.
7. So
Ah,
in layman's term, water is neutral, 0.7. Okay, so let's go back here. So as you add your uh, titrant, no, you release, you open your knob, and then the base is added on the solution. So does the volume inside the flask increases or decreases?
increases.
Correct. And as you can see,
It
the
changes color.
phenolphthalein change in color, and that is where you close the knob and you read the
Oh, okay.
binary.
Okay.
So based on the theoretical or based on this diagram, do you understand how titration works?
Yes, yes.
Okay, so it's clear drawing. Okay, I'll show you a video because we have just um we have I'll just show you a video just in case. Um, okay, GIF na lang. Okay, can you see how? Oh,
It changes
ayan no.
color.
As you can see no, as the base is added no, you open the knob, and as the base is added from red, the metal red changes from red to yellow.
Hmm.
So at pH red, what's the pH at the color red when it's red? What's
Neutral?
the pH of the solution?
No, no,
No.
it's not neutral. It's acidic.
Okay. And then when it turns yellow, what's the color?
Becomes more
What's
basic.
the pH? Correct. So this is what happens usually in titration. So titration curve. Okay. So as you increase your as you increase the volume of your titrant, for example, this is your acetic acid. and your sodium hydroxide. So acetic acid is a weak base, by the way. So what's the difference? Weak base, no, it doesn't it dissociates easily. Strong base, strong acid, it doesn't dissociate easily. So by the way, so the color change is the equivalence point. So what's the equivalence point? So the equivalence point is where you have an equal amount of your acid and your base. Okay.
Okay.
So in here, at when you have zero volume of your, sorry, if you have zero, sorry, ah, wait, okay. So in here, no, what happens here? So you in here you have a zero volume in your tritrate, right? Zero here,
Yeah.
and the pH of your analyte, which is your acid, this is your acid, this is your base. Okay. Okay. So the pH is at 2. Let's say you don't have your base yet. So this is your acid. This is where your acid is, no?
Hmm.
And then acid. Starting. Use different color. Use dark. And then as you add the volume to your tetrad, no? You add the volume, the pH changes from 2 to 4, no? So what happens
Yeah.
here? What happens here?
So it's becoming less acidic.
Yes. So you have your acid plus the addition of your base. So in this case, which of the following has a greater concentration? Is it your acid
Still
or
the
your base?
acid. Still the
Correct.
acid.
Yeah. So as at half, so let's say at the volume of the third can, no? As you can see, the pH of the solution is at 9. And the equivalence point has an equal concentration of your what?
Acid is equal
Acid
to
and
base.
your base.
Base.
Okay. In this case, what happens here in
The
this
base
area?
becomes greater.
Okay, correct. So you still have your acid here plus base, no? You have your acid plus base. But what happens? But your base has a greater concentration or
Okay.
amount. And on this part, on the plateau part, no, you have an excess of your base.
Okay.
That's okay. So it means no, when you said excess base, all of the acids are consumed, and you just have an excess of base. No, that's why it plateaued at pH 12. You understand?
Okay. Yes.
So in this case, which is the excess, acid or base
Acid.
in this area?
Acid.
Acid. Okay. So that's why here. Okay. That's why uh you have the term endpoint of titration. So meaning it's the end of your titration. You have an excess of your base. So like for example, in our case, uh from red to, let's say, the endpoint is yellow. So from red to yellow, the endpoint is the moment where the color changes, an abrupt change of red to yellow. So beyond your endpoint, it's your excess over titration. No?
Okay.
So do you understand
Yes.
how titration happens?
Yes.
Okay, sige, teka. So, ito pa pala. So this is your titration curve, no? So at every addition of your volume, you record the pH. So this is your pH 1, pH 2. So you have a table of your volume added and then your pH, no? So based from the table, let's say 0, 0.5, 1. You check the pH, 2,
Same.
2.5, 3. Yan yung ma-generate na curve. no? From your Excel, no? Okay, I'll give you a example. Go to Google Slides, Google Sheets. Okay? O, ito, binigyan na kita ng practical sense. You have a lecture, you have a laboratory. Okay. Okay na i-delete this. Okay. Okay. What's your acid? Oh, name an acid. What's your base?
Hydrochloric.
Oh, acid is based from our module. Our acid is, let's say, let's use this first. So, uh-huh. Ito muna. Phosphoric acid, H3PO4. Your base is your sodium hydroxide. What's your indicator? You use phenolphthalein. Let's kasi ano lang naman, strong acid, strong base. Okay. So, you should have your table, no? Volume of uh, your base added and the pH of the solution.
Okay.
Okay. What does the manual say? What's the increment?
0.5.
From 0 to 0.5. So this should be in. Okay. Let's say, okay. This is just ano, no? Hanggang pH 12. So
Okay.
let's say the pH here is 2, 2.3, 3.3, 3. There are cases though, sometimes the pH can be 2 point, can go back to 2.1. No?
Okay, so you're just there's no like definite answer. It's just depending on how much increments are added.
Yes.
Okay.
So this is just a ano, what do you call this? An example.
Okay.
So let's say this is your ano, this is your equivalence point. This is an example. So what's no, this would be your equivalence point. Kasi half is your, I guess half. No.
Oh.
Around, or let's just say around this value is your equivalence. This is your pH level.
Well, how do you assume where's the equivalence point?
No, I'm just quoting points.
Okay.
Okay, 3.3, let's say 4.5, 1.0, 5.7. These are just assumption, some assumed values.
Okay. Okay.
Okay, 0.5, 7.4, okay, 8, 8.3, 4. Let's say bumalik ng 8. That's possible. Pero it's an error, no? Error for your and for your 5. Okay. For example, this is your equivalence.
Okay.
How would you generate your citation? So, just have to here, no? This is your x-axis. This is your y-axis. Mhm. Just have to select, no? So both of them. Insert chart. Okay. And you will do a
Whoa.
curve like this. Wait lang. What happened? Oh, mali ang values ko. Sige. Um, dapat gaganon siya. pH of the solution. pH.
It I
Dapat mag-plateau na siya.
mm,
No. I was wrong. Abrupt change. So, at volume 7, there should be a change here. It should, 7. It should be ano, around 11. So let's say 2, 3, 4, 4.5, 4.8, 4.7. Ayan. Oh, that's possible, no? So, uh, okay, let's annotate. Oh, here's your acid, right? At 0.
Yes.
Oh, as you add your base, no, the curve goes up. And at volume of 7, let's say this is your equivalence point, there's an abrupt change, okay?
Yeah.
And then it plateaued here, right? You
Yes.
don't see the plateau, it's okay. But as long as you see a steep curve, it means there is a reaction that happened. Here's the equivalence point. If you trace that, you'll see the page here. It's around what? 7 to 7. So do you understand now how to create a titration curve?
Yes.
O ayun. So you request the video kung gusto nila ma'am. Ibigay sa'yo. So that's how you ano no. This is eight. These are the values that I gave you are just assumptions,
Okay.
but this would be the trend in doing your titration. So there's a gradual there's a progressive change that is very minute, and at a certain point there will be a spike at the equivalence point. So if you see a certain spike, no, so you just have to get the trend line, no, you just get the endpoint, and the endpoint goes here. Pero just since you're not a biochemist, by inspection, the equivalence point is the pH, no, where there's a huge difference between two pH, no. What do I mean? Oh, tignan mo dito. From pH 5, no, it jumped to pH 8.7. From
Yeah.
8.7, it jumped to 11.
Yeah.
So as you can see, it's the center. That is your center.
Okay.
Ito yung pH 8.7. Okay? So, ang tansya natin, 7.5. Pero, if we do the, say this is your 7, 7, and if we draw a line, ayun, pwede pala. No? If we draw a line here, so it's around, your pH is around 8.7. Naintindihan?
Yes.
Oh, yan na. O ganyan lang papakita nyo sa module. So, sige, we still have,
Seven.
okay. So, we still have 7 minutes. Gusto sana kita pagawan ng sample problem. I guess pwede naman. Teka. Ha? Sige, pwede naman. Pwede naman. Ah, di. Pwede naman. There can be times na there are multiple steps, ha? Kasi ano to? Polyprotic acid. So, let's see for what's the titration curve of your um, H3PO4 titration. Eto, this is the exciting part kasi kailangan nyo to. Okay. Ayan, no? Ah, tingnan mo naman. At PK1 of 2.2, no, you have a greater concentration of your
Acid.
acid, which is this is your acid, this is your base. Oh, what are the prominent species here? Sige nga, based on what I labeled, what are the prominent species?
Prominent species. Is it the H, the hydrogen?
Mali ako.
Right.
So you have a great, yeah, this is your acid. Bakit? This is your acid. Kasi, di ba, it has the acidic form, which is, it has three more hydrogens. And this is your base. Oh, hindi to head and shoulders baka. It's the ratio,
Yeah.
no? It means na there's a greater ratio, there's a greater value of your acidic triprotic, no? As we said a while ago, usually triprotic means three. Then your diprotic form.
Okay.
Mm. So it means that A has a greater value than B. Okay? It's for PKA, PK1. So at PK1, so previously I told you that the hydrogen here will be removed, right,
Yeah.
to form this. Okay? Okay, so dito naman. So this is your steep curve. So this is the equivalence point. Ayan. Okay? Magpa-plateau siya ulit. Although this is your PK2, what happens here in your PK2 is from your bakit yun? Okay, makes sense. O bakit makes sense? Bakit mas marami itong si letter A compared to B? Sige nga, just quite challenge for you.
Why is the acid
Why
greater
is
than
A greater than B? Yeah.
it's by the power of two.
No, this is a church, ha? O
Uh
sige, another guess.
Another guess. Okay, this is not
Wala na.
okay.
Okay, sige. As you can see here on the curve, no, nawawala yung what? Nawawala ito. And you have the formation of this, right?
Yeah.
This is your center. So as you progress, no, and this is your PK2 based from literature. So technically, beyond this, you have a greater value of this than this. Is that
Okay.
correct?
Okay.
Kasi dito, no, meron to, marami dito. Marami to. Pero at this point, it plateaued. And dito, lumiliit siya. So that's why this has a lesser value than this. Oh, okay, let's go now to the next. O dito, no, marami pa to. Marami pa siya. But in this case, dito, lumiliit siya until such a point na what? Actually, mas hindi ko nga alam ba't ito
The base.
compared to it.
The base is greater.
Baka, I don't know bakit ganito. So, bakit ganito? It's the trend. Triprotic, triprotic. Monoprotic, triprotic. Monoprotic, your base. Okay, wait lang. Bakit mas marami pa rin? Hmm, this is your, what? Teka lang. Check. Bakit is PO4? PO4 na to eh. Baka mali lang siya ng label. Pero you get the point naman, di ba? You
Yes.
get the point. So as long as uh, so when you do your titration in the laboratory, ganito dapat lalabas. Okay? This
Okay.
is the behavior of your phosphoric acid in acidic and in basic form. So
Okay.
at the end, at pH 14, your the prominent species is just PO40.
Yeah.
I have a question for you. In this case, ano ang mga species on this area? Andito na. Ito na. Itong dalawa. This is the midpoint of this
Yeah.
and this. Okay? So the species are this and this. Before this point, ang prominent ay what? Ito, right?
Yeah.
Dito naman, ang marami na ito.
PO.
Okay?
Yeah.
The phosphate. So okay, this is your phosphate and ion. Why is it an ion?
Negative.
It's your conjugate base. It's your base, actually.
Okay.
So was this discussed during your laboratory or laboratory set?
No.
Okay. So you were expected to know this in your if you don't have if you have a general chemistry class. But I heard from one of your teachers, of your professors that you didn't have a general chemistry class last semester or last year. That's
Yeah.
where you're having a hard time.
Yeah.
Okay.
No,
Then it's
because what happened was
okay.
our biochemistry class, this one got delayed by 3 weeks. So they're kind of just, giving it them out already.
What? Sorry.
Our biochemistry class, there was a problem and then got delayed by like 3 weeks. So they're kind of like rushing it out already.
Yeah. Okay, yeah. So I knew that issue anyway. Anyway, so I think, sige, send na lang for 3 minutes. Let's say, but I guess you know now how to do your titration curve, what
Yes.
happens during your titration curve,
You.
and the theory behind your acid phase. So, ayan lang. Oh, as you can see, page 1. Oh, you know naman na this, di ba? You know how to
Yeah.
do number 3. Or you
Yeah.
know how to plot. You know how to titrate. Or
Yeah.
you have to compare. Or you just have to compare. For phoric acid, ganun siya. I don't know for aspartic. For glycine, I guess ganun lang. Glycine, what's the formula of glycine? It's monoprotic, no? Oh, a clue. Oh, last, no? Clue. Triprotic acid versus monoprotic acid. How many peaks or how many equivalence points will you see for triprotic?
Three.
3 EP. Oh, how about in monoprotic?
One.
1. Oh, yun ang clue, ah. So if glycine is monoprotic, the curve would be like this, no? O pag diprotic, how would be the curve? O, i-annotate mo before we end.
All
For
right.
diprotic,
All right. One, two, three.
mali yan.
What?
Diprotic lang.
Tripod.
Di, di.
Die.
Oh,
Okay.
so this is one. Ay, sorry, this is your diprotic pala. Oh,
I like
this is correct. This is diprotic. Oh, you do that triprotic.
yeah.
Oh, you do the diprotic.
There.
Okay. So that this is 1, this is 2, and this is 3. Oh, very good.
Okay.
That would be the behavior of your titration. So I
Okay.
guess I guess for today we covered titration,
Yeah.
no? Basics of titration and ayun basic of titration and preparation and titration. Ayun, basics of titration basically.
Okay.